So I think this is a multiple choice.
Yeah.
Multiple choice. So do you think you're better with multiple choices or like question and answer style question?
I'm probably better with paper twos because I've practiced more of them.
Alright. Okay. So you're like less. You think you're less confident in.
I think so.
But generally, I mean, multiple choice question would be generally easier.
Yeah,
because you already given the answer.
It's just because I've been practicing
Yeah.
paper two a lot.
So let's start with question 1.
C.
Right.
C.
So can you just explain maybe?
Okay. So
Okay. So right. Sorry. This does not. Like it doesn't go. So okay. So what? So right. So delta H it can be positive or negative. So what does delta H positive mean?
sorry, no. Bond breaking.
Right,
Okay.
yeah.
So bond making is
So delta H positive
is endothermic.
So it's endothermic.
Yeah, and it's So it would be B. Then.
Negative is exothermic.
Yeah. Because combustion is exothermic.
Mhm.
Bond making is
also exothermic.
Also exothermic.
So that would be negative.
Yeah.
So bond breaking is endothermic because you put in energy.
Yeah.
Break.
So it's B.
Question 2. So the way to start thinking about this question is, I think, so the first question we would ask ourselves is, what is an ideal gas?
Mm-hmm.
So what is the definition of ideal gas? What is the definition of ideal gas?
An ideal gas is a gas where its volume is proportionate to the temperature and number of moles.
Yeah, so it's directly proportional. So which means if you draw a graph, it would pass through the origin.
Yeah.
So that's kind of assuming that the gas molecules it has no volume.
Yeah.
And the other.
So it also assumes that there are no attractions between the particles.
Yeah.
So weaker intermolecular forces.
So there's no attraction between.
Yeah.
So that would be DT. So all those things, those two, it does not change the definition. It doesn't. So there's no definition about the pressure and temperature. It does not change the intrinsic property of the gas. So this will make it further away because if it's more polar, then there's more interaction force. Number 3. This is a calculation. Question. You might want to write.
I think I'll need the.
So yeah, the purity
table.
I haven't got it with me.
I can go get one.
Okay. what's your approach?
Okay.
Of doing
So
this question?
I'm gonna find out how many moles there are in these 101.1 grams of potassium nitrate. Then find out how many moles there are of the nitrogen in that.
Yeah, so there's twice of the nitrogen in this one, so you just times it by 2.
Yeah.
Maybe you want to try to calculate this question. So this is the number of moles.
Do we have to calculate it?
No, that's fine. So, and then what is the number? Then what's the amount of the urea? How much urea? So this is number of the moles of the potassium nitrate.
Yeah. So then we would have half of the moles of that for the same mass of nitrogen.
Yeah.
And then I would find out the moles of that. Then I would know how many moles of that, and then that times the MR of urea.
Yeah, so the number of moles of the urea is equal to half of the moles of the potassium because it has got 2 nitrogen and this has 1. So this you just divide by 2 and then this is more.
Yeah.
The next question. So this is a mass spectrum. Do you know what mass spectrum is?
Yeah.
Do you know how it works?
Okay, so it can't be this.
Why it can't be?
Because there aren't any 63.5 isotopes of carbon by themselves. So the mass number can't be equal to
0.5. So the mass has to be an integer.
To a whole number.
Yeah, so like we have the decimals is because they are the average.
Yeah. And then so what I would do is calculate. Well, it can't be this too. Actually, no, it could be this. So I would actually it might be this. So I would calculate the abundance of the isotopes times the mass numbers divided by 100.
Yeah. So you're just calculating the average.
Yeah.
That's a good question.
Okay, so they're asking which has 5 electrons in the S.
S orbital.
Yeah, S orbital. So sodium. Yeah.
So this has 2. This has 3, 4, 5. And you don't need to go to the P block or D block.
It's just the S block. So it would be sodium. Okay. So it's not done.
Why are they not?
Well, none of them are actually metallic.
Yeah.
That has nothing to do with
so ionization
this one. Yeah, it's A. So silicon does have a greater nuclear charge than carbon, but the distance overweights that nuclear charge, thus it's weaker. So the distance between the outer electrons of silicon, the nucleus is
Yeah.
greater than that of carbon.
Right. So actually, so for B, a greater nuclear charge would result in a stronger bond.
Yeah.
But in this case, it's a reverse because although it has a greater nuclear charge,
The
but
distance.
distance is larger. So what is the structure of this?
Okay.
So how many pairs is around nitrogen?
That's so nitrogen has 5 outer electrons.
So you have a bond here.
So you have one bond pair here. You have 2 bond pairs there, and then you'll have a lone pair.
Yeah. So you have like 3 kind of
Yeah. So
bonding.
you have 3 bond repulsions.
Which is
which is 120.
so it's a trigonal planar.
Yeah.
Structure, and it gives you 120.
Okay. So
Yeah. So the first step is to draw the structures and to find which bonds have been formed and which bonds have been broken.
yeah.
So which bonds have been formed in.
So and then I would just do the bonds formed minus the bonds broken.
Yeah. So and then which. So you would.
So I would put the bond energies
Mhm.
in. So okay, what I would end up with is 3 times 110 plus 360
Mhm.
plus 460.
Okay. Yeah. So
whatever.
So it's right to use the
minus.
Yeah.
That would be minus.
So because minus means
Yeah.
exothermic. And bond forming is exothermic,
Yeah.
so it has to be minus. So because it will give you a different sign in the question now. So first, what's equilibrium constant? What is the expression for equilibrium constant in this reaction?
For this one?
Yeah. And you have the concentration for those two, and you have the equilibrium constant, so you can just do the equation.
Yeah.
And get the answer. Yeah. So question 2. we can just go them one by one. So from A to D. So A.
So HSO3 acts as a base. No, it doesn't act as a base. So a base would be.
How do you define base?
So a base is a proton acceptor.
Yeah.
And it doesn't accept donates. Okay, so it's not A.
Yeah.
SO2 acts as an oxidizing agent. So an oxidizing agent oxidizes another while it's self-reducing.
So you need to say if there is any oxidation number changes.
Yeah. So this is +4. Yeah, it's +1. +4. Yeah. So there's an oxidizer.
Yeah. So it doesn't.
So there's no redox reaction. SO6 is an acid. Yeah. So this is because it donates its hydrogen ion. Does it?
But okay. So acid is a proton donor, right? So but is there any proton in this?
No.
So it can't be acid, right?
So if it was H.
Yeah, but it's not.
But if it was, then it would be an acid.
Well, it depends on, but this is not involved in that reaction, right?
Okay.
So that's not acid.
So then it's this.
So as a reducing agent, but is there any oxidation number change?
No. Right. No.
Yeah, so it can't be D, and actual discrepancy lies between A and C, right? So the C says this is acid, but actually it's not, because as you can see from this reaction, it takes up a proton and becomes that one, right? So this can't be acid. It is actually base. So the only thing left is A. So actually in this question, although it seems like it gives away a proton, but actually it doesn't, because this happens in water. So what happens is, so in this reaction, so question like it misses one step in between. So if you look at this reaction here, no, sorry. So yeah, so if you look at this reaction here, actually it doesn't. So if you look at
that
so here it takes a proton and it becomes H2O, but here also this is not. Right, so in this reaction, yeah, it actually does. This one, in this reaction, it acts as acid. So the reaction, so but the proton is not the base. So water is actually a base. So the water is the one which takes off this proton.
Then it would be reacting. So
right, so in this reaction, it acts as a acid, as a base, right? It takes a proton, it changes to water. But in this reaction, HSO3 minus plus H plus. Right. So this is a base, this is acid, this is a acid, but this one is not a base. So what is the base is that water is the base. Water is one which takes off this proton and give you this ion. So water is one acting as a base. But in this question, it just omits this water molecule, because when water molecule takes a proton, it becomes that. Yeah, it becomes this. So this is like another way of writing H plus.
Yeah, I get that.
So here is 2H plus, but actually just this H plus plus H3O plus. So water is acting as a base. So in this reaction, it does act as an acid, I think. But in this reaction, it acts as a base. So A is the correct answer. But C is definitely not correct, because it can't be acid at all. It doesn't have a proton at all.
Yeah.
And B and D, you calculate his oxidation numbers. They don't change, so there's no redox group.
Yeah.
So it has to be A. Question 11.
Okay, so it's not A because the position of equilibrium isn't changed. Okay.
So how is the position, right? So the position of equilibrium is not changed, so it has to be from BCD.
Yeah.
So how does the catalyst change the entropy change or reaction?
It doesn't.
Yeah, because when you draw the
Just lowers the activation.
yeah, when you draw that reaction pathway, lowers the activation energy, but the difference between the product and the reactant is the same. So this is a simple question. So question 12. So two resulting solutions have the same effect on litmus. So what does this statement imply? So what does this statement imply? Have the same effect on litmus?
I have no idea.
So what do you know what litmus paper is?
Litmus paper.
Yeah.
Yeah.
It has a
changes color.
yeah. So that means, so if it's right, so that means the both the oxide and chloride. So they change its color based on the acidity, right? So which means that both the oxide and the chloride of this element are the same, have the same pH property. So they are either all basic or acidic or all neutral, right? So if one is acidic and one is basic, they don't have the same effect.
Okay.
Or if one is neutral, one is acidic, they don't have the same effect. So they must have the same acidic properties. So
it can't be this.
yeah, because the oxide is basic.
Yeah.
Okay, actually, so also oxide, all those metals, they're all basic, right?
Yeah. Well, the oxide of aluminium could be basic or acidic.
Yeah, so it's yeah. So, but it has basic properties. So what about the chloride?
This has acidic properties.
Yeah, so the oxide of the phosphorus is acidic. Okay, so No, the second, the chloride. What is the property of the aluminum chloride?
Acidic.
Calcium chloride.
It's
kind of neutral. Right?
Yeah, it's neutral. It just destroys.
Yeah, and the same for that.
Also
What about this?
acidic.
Yeah. So in all four of them, only the phosphorus,
Yeah.
oxide, and chloride have the same acid-base property, so they would have the same effect on these.
So, litmus. So I know that ammonia changes the color of litmus paper. So is it that if it's a basic property, litmus paper will change from a specific color to another?
Yeah, so it only tests.
And if it's acidic, then it'll change from another color to a different color.
It depends on what types of litmus paper have.
Okay.
So I think there are acid. So there are ones to test acid, which should change color if it's acid, and there are ones which to test base. And also there are like pH indicators. But it doesn't matter which one you have.
Okay, so what they're literally asking is which one has both an oxide and a chloride, which is acidic. But basic.
Yeah. So which one has the chloride has the same acid-base property.
Okay.
So question 13.
Which packing system?
So maybe we can just go from A. So what is type of bonding in aluminum and what is type of bonding in phosphorus? So what is the type? So maybe just go from this element.
Metallic and chemical. I mean covalent.
Yeah. So not A.
Yeah. And then covalent and nothing.
Yeah.
Metallic and covalent.
Yeah.
And then covalent.
So it's D.
Yeah.
Number 14.
Right. So
So which one of them are precipitate in water?
this is not.
Yeah.
This is not. So far, so yeah. Excess. So this one's not. This one's not.
Access. Access just means that it completely reacts with the other one.
Okay, so then they are.
Barium hydroxide is not. So it is a precipitate.
Okay.
But so that one is a precipitate.
Okay.
So magnesium hydroxide, I don't think it is a precipitate. I don't think magnesium hydroxide is a precipitate. So what about carbonate?
Yes.
Yeah, so carbonate,
No.
they are precipitate. So magnesium hydroxide is not. So how many precipitates?
1, 2, 3.
Yeah, so that one is not. But this one is.
Okay, but I thought that group 2 hydroxides get more soluble as you go down the group, right?
Let me see. Yeah, but actually I don't know this. Let me maybe reconcile it. Yeah, so this is soluble in water, but this is not. So going down the group, I don't think it increases going down the group. So what determines the solubility?
The ability to dissociate.
So what happens when you go? So when you go down the group, the radius of the cation increases, right? So it increases, which means
To have a less stronger pull towards the hydroxide group.
yeah, but also when you dissociate in water. So basically, so then that determines solubilities. So when you go from a solid to a solution, you are breaking the bonds in the solid and reforming the interaction between the ions and water molecules. So there are two factors. One is the strength of the bonding in solid, and the other one is how strong is your solvation. So how strong is the interaction between the ions and the water molecules. So this is what. So because when you dissolve it, you are like taking apart the bonding in a solid. For in this case, which is ionic bond, and then when you dissolve it, you have to compensate for the bonding that was broken. So you compensate by having an interaction between the ion and water molecules. So in solution, for example, if I have magnesium ion, that is plus. That is positive charge, and I don't know if you learned this, but so in the water, the oxygens are negatively charged, and the protons are the hydrogens are positively charged because of the difference electronegativity. And what happens is that the oxygen bits surround this cation, and it forms an interaction between the negative oxygen and the positive magnesium, and this interaction is determined by this kind of electrostatic interaction. So which means the stronger the charge. So because like charge repulse and unlike charge they attract each other. So the stronger, but the negative, so the charge on the oxygen won't change, but the stronger of the positive charge, the stronger the interaction. So the stronger the interaction, the more likely it will be soluble. So if you go down the group, the cations they become larger. So they would have a smaller charge to radius density. So you would have a smaller interaction with water molecules. Although you have another counteracting factor, which is you have less bonding strength in the solid. So it's like two factors, they counterbalance, and the resultant is, it's not, unless you quantify it. So it does not necessarily have a trend.
Okay.
In this case, I think. Yeah. So yes, although you go down the group, the ionic interaction in the solid decreases, but also the interaction between the cations and the water molecules also decrease. So it depends on how these two factors balance with each other. Yeah, but in this case, this is soluble last one.
Okay.
So question 50. So what is the reaction happening here? And so to calculate the ratio, to calculate the molar mass of that, times 4 and divided by.
Yeah.
So gas X, so you don't need to know which is X, which is Y, because
Y is oxygen.
Yeah, you have the things here. All right, Y is oxygen. So you're just calculating the molar mass and divide it. So it's question 16. Is this a reaction between manganese and water?
And steam. Yeah. Okay.
So A is.
I would say.
So A is correct.
Yeah,
B is.
that's correct. That's correct. That's incorrect.
Yeah. Most of the.
So it's not very soluble.
Generally, the metal oxide is also soluble in water. Question 17. So which one of the chart is correct? Or are they both correct?
Seems pinky last to draw patches. And the compounds different language. Soluble. Okay. Solubility. Silver iodide is insoluble in NH3, and Cl is soluble in
Yeah.
The other is semi-soluble.
Yeah.
So this is incorrect.
Yeah. So you remember the practical.
Yeah.
The observation to distinguish between the three. So yeah, this is not soluble. This is soluble. So this is not right. The other way around. What about student Q?
So they're saying that all of them are exothermic.
Mhm.
And then this is the most exothermic.
Yeah. So has she joined correctly?
Huh?
Has he joined correctly? Is this diagram correct?
Do I get the data booklet on this to check out the bond?
You don't have to. You don't
I
need
don't
to.
need to. Okay. Because I know that.
Okay, so you are saying that. Okay, so you are saying that this in this chart, so what she means is this chloride is more smooth exothermic, or are you saying that the chloride should be most exothermic?
I know that like you need to put energy in to break these bonds. This one doesn't matter because you have to break.
So you don't need a data booklet for this. So if we think about this, so what happens in this reaction is we break in this bond, right? But all of three of the reactions they break the H bond, so this would make a difference. So this would make difference.
Yeah,
that would make a difference. So going from chlorine to iodine. What happens to the bond energy of the hydrogen molecule?
Decreases.
Yeah, so it decreases, which means you need less energy input, right? For this reaction to happen. What are the bond strengths of that? The HX.
Increase.
Yeah. So what determines a covalent bonding strength?
The overlap.
Yes. So because chlorine is a smaller molecule, has a smaller atomic mass, so you have a shorter bond. So going from HCl to HI, you have going from HI to HCl, you have an increase in bonding strength, right? So those two factors, which means HCl has the strongest bond formed, and right. Yeah, actually, I think you're right. You do need a data.
Right.
Yeah.
I need the bond. Yeah.
Yeah, you do need.
Okay.
Yeah, because I thought both all the factors they go the same way, but actually no. So yeah, so although this bond is stronger, but I also have a stronger bond to be broken. But yeah, you do need the data booklet, and you just calculate the entropy change.
And then.
Yeah, I think you're right. Yeah, because you don't know which factor is
more.
Okay. So question 18. So you read the question?
Wait. Okay, so purple upper layer is that they contain diatomic molecules of iodine.
Yeah, so that means there is iron.
Yeah. That means that 1, 2, 3. Yeah.
1, 2, 3?
Wait. No. One.
Oh, okay, right.
No, wait. Sorry. Yeah.
You think this 3 is iron?
No, wait. Okay, sorry. I'm so sorry. So actually, so
how?
No. Okay. So, I'm so sorry. Okay. So this is a displacement reaction.
Yeah. So how do the reactivity work?
Yeah. So the more electronegative atom replaces the less electronegative.
Yeah. So what?
Ion.
So what about the?
So
How do we rank them in terms of activity?
goes up.
Yeah.
So that's the most.
So chlorine would replace all of them.
Replace, and then iodine will be formed here.
Yeah.
So that's one here, one, and then bromine would replace.
No. So would they replace?
No, it wouldn't
Yeah.
replace. It doesn't matter, and it would replace.
Yeah.
So that's two.
Yeah.
The iodine wouldn't replace, and it doesn't really matter, even if it did replace.
So what's the answer?
So three. Because iodine is already.
Right, but what about 7 and 8? It doesn't replace. So what happens to iodine?
So it stays in the solution.
Yeah, so
that would be
yeah.
4 and 5.
Yeah.
So 5.
So those two because iodine is replaced out from the solution, and this one because it doesn't react, so it stays in the solution.
B.
Yeah.
Oh no.
So I think the first is to find the longest backbone. So what is the longest? Which is the longest backbone?
This.
Yeah. So what is it? What is it called? How many
1,
carbons?
2, 3, 4, 5. So
would be a
pent.
yeah. So it can't be A and B.
Yeah, that's
So
very good.
So we choose from 3 and D.
Yeah. This. Yeah.
So you can have like 2 or 3. So the number it depends on which way you go. Right?
Yeah.
So both are okay.
Okay, wait. So 1, 2. Okay. Sorry. 1, 2, O, and 3. Yeah, that makes sense.
So what about 4? Number D.
Well, it's hydroxy. It's an alcohol. So, well, I don't know why there's.
Right. So if it would be.
It doesn't even 1, 2, 3. Yeah. Doesn't make sense. So I don't know why you would do put hydroxy and not O.
Yeah.
Because it's an alcohol.
Mm-hmm.
So it's not.
Yeah. So 21. Awesome.
Nice. Hydrogen. Okay, wait. 2.
Yeah. So I would draw all the products.
Okay.
To begin with.
So it's electrophilic addition. So. It's 1. Yeah. And that doesn't. No.
Well, are there any other products?
Well, yeah. Do you want me to draw them?
Yeah.
Okay. No. Sorry.
That's H.
Yeah, that's
Okay.
an H. Oh, that's sorry. That's yeah. Okay, and I think there's a non-material.
So that's
Oh no!
that
Wait,
has
wait. Sorry. There's also BR. So if you have BR and BR.
is there any other
No.
other products? So right, so yeah, you got behind. So which one then?
Contain a chiral
Yeah.
chiral center. Okay, so this one,
Mhm.
that's a chiral center.
Yeah. That one?
No,
No, it doesn't.
no chiral center. And this one, yeah.
So
It's a chiral
two.
center. So two.
Yeah. That's two. 22. Maybe you want to take a break. 5 minutes, or you want to continue?
I'll just continue.
Yeah.
What is the structure for okay. Okay. So
let's
you
first,
create. So okay, I'll just do X and Y, right?
yeah. So first, yeah, what happens when you have this?
You create a primary alcohol.
Yeah. So it reduces.
Yeah, it reduces. Right.
Mhm.
And then here you create a carboxylic acid.
Yeah.
So, well, OH. And then you produce an ester.
Yeah. So you couple the two functional groups,
Yeah.
and you have ester. So you need to find.
So it has 4 and 4.
So which one? So you would have CH3S3. So you would have 3S3 here, right? Because you need 4 carbon at both.
Yeah, so you need 4 and then on either side. So 1, 2, 3, 4. 1, 2, 3. So that's not it. 1, 1, 2. Yeah.
So which one?
1, 2, 3, 4.
So this one is 5, right? No. That has 4.
This could be. Oh. How do they differ? 1, 2, 3. Oh, 4, 5. Okay. This is. I think it's this one.
Yeah.
Just checking. Yeah, it's that.
Yeah.
Okay.
So this one that has 3. So the count doesn't work. This is 4, but you have 7 here. So
No.
Yeah. Anything.
Okay. Okay. What different? So it could Okay, so an H could come from methyl group. Yeah.
Yeah. So what happens in this reaction? What happens with this molecule and the chloride free radical?
This becomes a free radical, and then HCl is formed.
Yeah. So it basically this one takes off one proton from this molecule. So you just need to so if it takes a proton, so it can take protons from different positions, which will give you different products. So which positions can it take?
This position.
Yeah.
That would be the same.
Yeah, that will be the same. Yeah.
This one.
So all those three gives you one answer.
Yeah.
This one gives you another two different answers. So three total. Question 24. Yeah, so it's actually, so all those bits are not useful. The only useful bits is from this.
So no. So it has to be hot.
Yeah.
And
so it's just a matter of aldehydes or ketones. So it's aldehyde and final product, oxidation product of the.
No, it's not.
Because it can be
oxidized.
it can be further oxidized, so it has to be 25.
Okay.
Right. So what does this graph tell you? What does this graph tell you? So what kind of reaction is it from this graph?
I don't know.
Well, yeah, but that's not kind of related to the question.
No.
Because it's actually. So what are the information can you get from there?
Two intermediates.
Yeah, so it has two intermediates because it has two peaks. So what does it mean in terms of reaction pathways? Do you have two intermediates?
Yeah.
Which means how many steps do you have for the reaction? If you have two intermediates.
4, isn't it? No.
How many steps? If you have just one intermediate, how many steps?
Then you have 1, 2, don't you?
Why would you have two steps? So
no. You have one step. You have one intermediate.
Yeah. So you have two intermediates.
Steps.
Yeah. So it is two-step reaction.
Yeah.
Which means it is SN1 or SN2.
SN 2.
Yeah, because 2 means that it has two steps, right?
Yeah.
So now you know what this graph means. So now you need to work out which one is SN1, which one is SN2.
Sorry, is SN?
Oh, sorry, not
SN1, right? SN1. It's SN1 because SN1 starts with SN1 has two intermediates.
Yeah, right. Yeah. SN1 is because there's only one.
There's only one
involved in the redetermined step. So there's only one species involved.
Yeah.
So you have to.
So where would you have two intermediates?
So would not have such pathway, so you need to find the one which you have only one step for reaction.
Oh, it's A.
Yeah. Actually, it's not necessarily SN1. It's just a two-step reaction because it's not necessarily a nucleophilic condition. Because, for example, this one.
Okay, that's weird.
So this is just a one-step reaction. But
that is a nucleophilic.
So if you compare A and B, they are either S1 that either SN1 or SN2, they are nucleophilic reaction.
Mhm.
So this one is SN2, right? This one is SN1. Do you know why?
Okay, so I know that that's only bound to one alkyl group that I did. And that's bound to this alkyl group and this alkyl group, so two. So it has a secondary structure.
So this one has a secondary structure.
Yeah, and that has a primary structure.
This one is actually a tertiary,
tertiary structure, and that has a primary structure. So primary nucleophilic substitution is always SN2, and tertiary is SN1. Yeah,
but why would tertiary be SN1?
Because that two.
Sorry, why would tertiary be SN1?
Because the way it works is that the bond breaks, forms an intermediate. Yeah,
but why this one? Wouldn't this one become an intermediate first? Why wouldn't this one?
Because it's the carbocation is less stable.
Yeah. Yeah, so because it forms a stable carbocation, so it would break first.
Yeah.
26. It is calculation. So what happens in a complete combustion reaction of the organic molecule?
You get CO2 and H2.
So all the carbons in the carbon chains, they become CO2.
Yeah.
So in this case, you just need to find how many carbons.
Yeah.
And then work out the moles.
Yeah. And then you know that 24 cubic decimeters is 1 mole.
Yeah.
Yeah.
27. So first
so
part.
What it's saying is it reacts with sodium to give H2, hydrogen, but it doesn't give the yellow precipitate.
Maybe we look at the first bit first. So to give a combustion gas. So yeah, we react with sodium gave H2, which functional group.
So that's alcohol.
Yeah. So which means it's B or C, right?
Right.
The second alkaline aqueous iodine. So which kind of alcohol gives precipitate with?
So it's a secondary. A secondary alcohol would give precipitate with a CH methyl group. So it would have to have this.
Yeah. So a secondary alcohol would give a precipitate. Yeah. So C would give a precipitate.
Yeah.
So that's not, but it does not.
It does not.
So
it's
left with B. So we can start with what happens when you interact with chlorine gas?
Okay. You form chloropropane, but you also form different.
So you would form one position as well as two positions, right? There's no selectivity.
So you form different products.
So that does not give you the best yield.
And then dilute NaCl.
That don't react.
Doesn't react even.
It doesn't make sense. So say
that would react.
yeah. So how does this reagent do? What does this reagent do? So it changes. This reagent it reacts with alcohol.
So it forms sulfur dioxide, higher hydrogen chloride, and it would form 2-chloropropane.
Yeah. So that because there's only one alcohol group. Yeah. And this one only reacts with the alcohol group, so it would only have two. It would only have chlorine at the 2 position. And that one.
This one would create 2.
Yeah, so you would have in different positions.
Yeah, so it would be this one.
Yeah. 29.
Oh. Okay, so it's not this or not this. What is this?
Maybe draw the structure of this test.
This one?
Yeah.
Okay.
When you draw a structure, you don't always have to draw the carbon. You can just draw the skeleton.
Okay.
So it saves you a bit of time in the exam. For example, if you want to draw this, you can just draw it like this. Yeah. That will save you time, and you don't even need to draw the hydrogens. So when it reacts with the sodium hydroxide, so how does the sodium hydroxide react with the acid?
It forms an ion.
Well, yeah.
So it will bond to the oxygen.
So this is acid we have, and then mix with sodium hydroxide in solution. So what happens with these 3 reagents in the solution?
So
what is the first step?
So you form an alcohol and you form a sodium ion.
You form
ion compound.
Yeah. So basically this. So that carbonyl here. Sorry, this carbonyl center is positive, right?
Yeah.
And this is negative, so it kind of attacks this carbonyl center.
Forming alcohol.
Yeah.
And
it takes out
oxygen.
So you're left with this carboxylic group and the alcohol group. So it kind of breaks this bond.
Yeah.
And this will be replaced by sodium.
Yeah.
So you have this one.
So you'll have sodium propionate. Propionate.
Question 13. Yeah, so it's like similar to that question. So instead of hydrolyzing it, I mean, this is like a tail biting. So to create this ester, you need a carboxylic group and an alcohol group, right?
Yeah.
So if you break this bond, you're left with a carboxylic group and a hydrogen group. So it's a bit like if you have this long molecule and it binds the tail. So the 2 groups at the end of the chain, they condense with each other and form this ring.
Yeah.
So you know the formula, you know the structure of this. It needs to work out which formula it is.
Yeah.
Which is so that can't be right.
Okay, so it can't be this.
Yeah.
Either.
Well, it can't.
Two
carboxylic. It can't be this.
So
this one it has.
I think it has one. So no, that's aldehyde.
Yeah, it does not react with it.
Yeah. So
this one has alcohol and carboxylic, so that's the right answer. Question 31.
Okay, this is just how to select answers.
Yeah, small.
Compound. Okay. So one has the second highest value, okay, and one has the third of the group, which is like that. So, okay, calcium, the third highest value of its group, and chloride has the second highest value. So it could be one.
Yeah.
Magnesium, second highest, and bromide, third highest, so it could be two. Potassium, third highest, and sulfide, second highest, so it could be three too. So it could be all three, so eight. There's unusual physical properties compared to results of. Yes, so one is correct.
Because we have stronger bonding, so that would result in a high melting point.
Yeah.
How about surface tension?
Two is correct. I think it is.
Yeah, because you have stronger bonding on the surface.
And then it's harder to break.
Yeah, it's harder to break the surface.
And then three is also correct.
Yeah.
Because it's harder for water molecules to.
That's right. So the stronger the bonding intermolecular bonding.
The higher the.
Yeah. So the more viscous always be with.
Okay.
Statics.
Okay. Okay. The shaded area represents the proportion of molecules. Okay, so let me just. Okay, I'm not sure about one as yet, but two, yes, that's right because that's zero. Then no, there's no. And then T2 is lower. No, T2 is higher.
Yeah, because you have a distribution.
So that's incorrect. That's correct.
What about A1?
I'm not sure about the wording of it. That's what. So the shaded area represents the amount of molecules with energy between E1 and E2 at temperature 2, which is correct, but proportion, so I would say yes, maybe.
Yeah, so
proportion is amount.
Because if you look at the y-axis.
Oh my gosh. Okay.
So
okay,
the number is the last right answer is B.
Yeah. One and two.
Next question.
Okay. That's correct. One's correct. Let me just. I'm sorry. Eight, 1, 7. Okay, that's right. That's right.
2. So from 5 to 7, it increased by 2.
And from 5 to 1,
Decreased by 6.
Decreased by 6. So, okay. Okay. Al. Okay. That's wrong. That's wrong. That's wrong. Oh, wait. Wait. Why is the first ionization energy less?
Well,
Okay, I got it. So it's from group 2 to group 3.
Yeah.
Okay. So the outer electron is more shielded from nuclear charge. That is correct, and it is further from the nucleus. It's not in the higher. Well, yeah, it is. So it's in the p orbital.
Yeah, so you solve it so like the other way around.
Yeah.
So that's why you.
Yeah, so it's all
Because when you go across a period, the orbital expands.
Yeah.
And
So it's
the
in the higher
electrons gets further away from.
It's further than shielded. So everything that I said is stop.
Okay. 36.
I'm going to use the colorless gas produced by the hole. That's correct.
Yeah.
Oh, correct. Ammonia is a base.
Yeah.
So it will increase the pH. Ammonia can be warming.
Made by warming sulfate with.
Yes. Oh no. Wait.
Ammonium sulfate. Does it react with hydrochloric acid?
I have to. Okay. So that's.
So what's the property of the ammonium sulfate? Is it acid or base? So you
ammonium sulfate is.
Ammonium
sulfate is an acid.
Yeah, when you dissolve it, you have H.
Hydrochloric acid is an acid.
So they don't react.
Yeah. If it was a base like calcium carbonate.
Yeah. So it's a base. It will take a proton.
Yeah.
You will regain the H.
Yeah.
H3. 37.
No.
Because it
More
decreases. Yeah.
electron. That's so it decreases
decreases,
the electron density. Increase, no, decrease.
Yeah, because it's less polar.
Yeah. Yes.
Mm-hmm.
Yeah, because the bond energy is less.
Yeah. That's right. 38.
Yes. Because it remains unchanged. Yes. Yes.
39.
So they're literally asking which ones have a carbonyl.
Yeah.
Yeah. So this one does. This one does. This one does. Okay.
Okay, hang on a second. So this is a carbonyl. What about that one? Is there a carbonyl group in this?
Yeah, that's carbon.
But do you have oxygen here?
Oh,
It's
that's an ester.
Yeah, it's an ester instead of
So,
carbonyl.
well,
What about that
and
one?
then this one is also an
Yeah,
ester.
so that won't work. So
Okay, so
wait.
I have to be careful. Yeah.
So number 14. Are they structural isomers? So how do you define structural isomer?
Same molecular formula but different
Yeah.
structure.
So
wait, I have to count the cards. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6.
Yeah.
This basically is all.
it's just
yeah.
oxygen changing to that.
So,
yeah,
the functional group structure. Yeah. So yes. Oh gosh. Do it.
So they definitely both have the same formula because
they have the same.
it's just a way to check if this is right.
Yeah. So I have to like literally just count 1, 2, 3, 4.
You already counted 6. Yeah.
6.
How many hydrogen you got?
4, 5, 8, 11, 12.
Yep. And 2 oxygen. So that gives you the right answer. It's number 3.
Totally wrong.
Yeah. Okay. Do you have any questions?
No.
So I'll stay on that.
Yeah, and I'll.
If you can send me which questions you want.
So I have okay.